Paper 1, question 27. PQRS is a parallelogram, N is the point on SQ such that SN to NQ is 3 to 2, so in English and layman's terms, it basically means that from here to here, if its length was 3, then N to Q, its length is 2, and more on that in part B. For now though, it says write down, in terms of A and B, an expression for SQ. And one last thing that's given on the picture and also given in words. The journey from P to Q is given as A. So the vector PQ is A. And the journey from P to S is given as B. Now it's asking in terms of A's and B's, and it's asking for an expression for S to Q, or in other words, the journey from S to Q. Okay? So that's what we're looking for. Now, all of this is down to what A's and B's represent and how they can be twisted and changed. A is the distance from B, A is the journey from B to Q. Because this is a parallelogram, it will match S to R. So I can also put that that is A. P, the journey from P to S, is the same as Q to R. So I can also add the A as B. The way that vectors work also is that from one journey to the other, if you were to take the opposite journey, you end up with the opposite vector. So from Q to S, if I were to have gone this way, that would be negative A. And if I were going from S down to P, that way, that would be negative B. Also, from here to here is negative B, and from here to here is negative A. And the idea is that using that combination, we can describe the journey from here to here. Now, first thing to point out is that this diagonal that you have here has got no arrows on it. It's got no A's, it's got no B's, it's got no minus or A's or B's. What's that about? Well, it just so happens that if you combine vectors together, you can describe one journey in a different way. Because the way that vectors work is that as long as you've gone from the start to the end of a journey, all the stuff that's in between, or all the detours and stuff that you could take, and kind of will cancel each other out, and you end up with the same thing. So from S to Q, I could go down here and along, or I could go along here and down. And it doesn't actually matter which way you go. If you use the A's and B's that are there to describe that journey, you will get your answer. So I'm going to go along the top. It doesn't really matter where you go, but if I go from S to R, I'm going A, is my journey from there to there. So if I take the journey A, I end up here. If I then go from R to Q, again, notice that's the opposite of what B is. I will take a journey minus B, or in other words, I will add the journey negative B. Say that again. The journey from S along to R is described as A. The journey from R down to Q is described as negative B. When you compound journeys, or you compound vectors, you're adding them together. So maybe compounding is not a good word there. When you take the sum of two journeys to give you one big journey, you're adding them together. A plus minus B is the same as A take away B. Of course, if you went the other journey, you'd have minus B plus A, but minus B plus A is exactly the same as A